Hello guys, my name is Diego Pacheco and this is another Rust video. In today's video, we're gonna be talking about Vec Adventures in Rust. Basically, I want to show you guys how we can do some common tasks using vectors, and also I will present these samples also using other data types like strings and stir, and we also will be doing that passing function parameters and returning function parameters, because then we can see the examples in form of borrow and ownership, and also lifetime enhancements that we're going to be doing to help the Rust compiler. And I believe in that way will be most useful for you guys. Okay, so I have some POC I want to show and we can take a look on the code. So let's get started. So let me open my idea here. I have a cargo project called Vec Adventures, and we can start from there. So I'll open it here on my idea. Let's wait for idea to open. There we go. So in this project, if we take a look on my cargo.toml, you guys can see I'm just using edition 2018. I really don't have any dependencies because I'm just using the standard library to do this video. So in my main.rs, I have a bunch of functions and a bunch of code where I also have the main method, and then each function is doing some different things with vectors, right? So let's talk about the vectors, basically. So in Rust, we have this type called Vec, which stands for vectors, right? So if I hold Control and click here, we can see the definition of a vector. It's a struct. You can use vector both as list to do list operations, but also you can use vector to do stacks as well. So it's a very, very useful structure in Rust, and I want to be covering in details. We're also going to see this macro called vec underscore. They're going to be used to create vectors as well. So let's jump into it. So first of all, I'm showing how we can create a Vec queue, right? In a Vec queue, it's a queue. This is how you can get a queue in Rust standard language. So I have this method called toVecDequeue, where we can pass a vector and we're gonna get a VecDequeue, right? So I am specifying types here. Let me make this a bit bigger for you guys. So get rid of this. Okay, now it's better. So let's take a look on here. So the first thing is this macro here, vec exclamation point, is used to create a vector. So I'm creating a vector with numbers, and I'm typing this as integer of 32. So if we take a look in this function I create toVecDequeue, the function receives a vector, which is a vec of i32, and gonna return a VecDequeue of our i32. So basically, in other words, we are creating a queue, and we are using a vector to populate this queue from the vector, right? And to do that, we just do VecDequeue to column from, and then we pass the other vector. Pretty simple, right? So Rust has this interesting thing that the last line, if you don't put a semicolon, it understands that's your return statement. So you could do stuff like, let's say I have a variable here, right? And Rust understands there's more code because I put a semicolon. But if I put a semicolon on the last one, it also it works, right? Because it's the last one. But Rust does an inference as well on the last one. You really don't need to put any semicolon there. If I don't put it here, as you guys can see, I have a problem, right? So on the last line, you can either put a semicolon or not, but the last line sort of is special. But besides that, so to create a queue in Rust from a vector is very simple. I just do this vec queue from and pass a vector there, and that's it, right? I can create a queue. Then I'm just printing that queue here, and that's it. So that's the first thing I want to show to you guys for vectors. Now, we want to do something that's very common, is to do conversions. And in Rust, strings are really a pain. And we're going to do two types of conversions. We're going to have a vec of strings that we want to turn into a vec of stir. And the other way around, that we have a vec of stir that you want to turn to a vec of string. So this is where sort of the pain starts, all right? So first we need to create two strings, all right? So if I just create like this, this is not a string in Rust, as you can see, it's a stir, right? Which is like a sub-view, it's like a view of a string. But that's not what we want. And there is like a couple of ways we could create a string. So we could use this method like string two column from, and then pass it something like here, right? Or I personally think it's more iterative to just call the to underscore string method here, and then we got the string, right? So we have two strings in Rust, and I also gonna comment why I have these many variables here, why I didn't pass it everything in line here, because Rust gonna complain about that. So I have two strings, A and B. Then I have this, I call it R2 underscore args, where I have a view of a vector, of a view of a string. And then I just gonna use this macro vec underscore to create a vector. And then I want to have a view of that two strings. And I do that by putting underscores. If I don't put underscores, as you can see, it's the string itself. Because we need the view, I need to do it this way, right? And the same thing for vector. If I don't want to have view, I do this, and then I don't have a view anymore, right? Yes. So you are wondering, okay, and then I have this string, this function called to str underscore vec. So we're gonna pass str vec, and I'm gonna turn into a string. Sorry, I have a string vector that I'm gonna turn into a str vec, and as you can see, the result here is a vec of str, and then I can print it, right? So first of all, why I didn't pass this whole thing right here, right? So one thing you're probably wondering is, hey Diego, you could do something like you're doing there, right, and do sort of a more concise programming, all right, and do something like this, do like this here, and like this here, and then that's it, right? Why don't you do that? Well, let me put the reference here because we need the reference, all right? And then you could just go here and put it in line, right? Well, at the first glance, it looks fine, right? But actually, as we try to run this code, we're gonna see that it blows. And it blows because it says that we have a temporary value dropped while borrowed, right? And the temporary values are this one here, as the Rust compiler tell us, right? So A and B are temporary, vectors temporary, and they're being dropped. So we need to have a longer lifespan. That's a one way to fix this problem, right? And that's why I was creating these variables here, so they're not dropped, right? And now if I go here, you're gonna see that we can build it again, right? So that's why I have all these variables in the main class this way. It's not short and concise, right? I found this a bit annoying about Rust personally. But anyway, let's take a look on the function now, all right? So on the function, here are some other things we need to mind, but one thing at a time. So basically, we are receiving a vec of string and returning a vec of stir. Don't mind these A's here, here and here for a moment. So what we're gonna do, we're gonna create a mutable vector of stir, and we do that by doing vec of stir new. So we create a new instance, and then we're gonna do a for in each item of the string, and then we're gonna push the item into the vector, and we're gonna be able to return the vector. So Rust has this thing called lifetime span or lifetime span annotations, where we have these hints we can pass to the compiler, because the compiler try to guess how long the lifespan gonna be, and sometimes the compiler is assuming it's shorter than actually is. So you can either put like apostrophes static or apostrophes r or apostrophe a. The most common ones are apostrophe a and apostrophe static. So you are not changing anything really. You're just giving some hints to the compiler so he can do a better job with the lifespan of the variable or of the reference. That's really what's going on here. So that's why I have this a here, and a here, and I really need that. So if I just drop this, it's gonna stop working, because what will happen is that you're gonna see that we are creating a vector here, and we are returning this vector. And then as this function is over, we need something from this function that, in theory we don't have anymore, and the compiler will complain. So I can show you guys if I just delete it here, right? So, and if I try to run, you're gonna see it doesn't work, right? Of course, here's expecting some lifetime parameter, right? Because I think, let me see, 39. Yeah, it's this line here. And if I, for some reason, I think if I remove those, let me see. Yeah, then it's complaining about the size, that it doesn't know the size ahead of compile time. When you want something to fail, you cannot make it fail. Let me see if I can make this fail. Let me see. Let me remove the references this way, maybe. Let me see. Yeah, it's complaining about the size. I was not be able to emulate it right now, but the problem is when I create the item, let me see if the problem is the color. No, the color doesn't have any lifetime here. I think if I clone, maybe it doesn't know. Oh, I can. I think maybe like if I put static. Let me see. Aha, there you go. So if I do it static, you see the function associated with a new is struct vec str, but bounds were not satisfied. All right. And anyway, because we are returning an instance, we really need to give this hint to the compiler. And basically, yeah, it's a bit weird. You need to put this a apostrophes here. But this just tell the compiler to the lifespan of this guy here is gonna be longer, and then you can work, right? I found this a bit annoying, but yeah, that's it could be some annotation here or something simpler, like do it, right? But anyway, is how the language works. Now let's see the other way around, where we have a vec, and then we're gonna get strings. So I use the vec macro, and then because it's a vec of str, I just can do this, right? And then I want a view of that str cnd. And I have a function to string vec, which is exactly like the other one. So you can see the lifetime span apostrophes here. And then I create a vec of string, and then I just do a for, and I add the item there. But the item is a stir, remember? I cannot add the stir on a string, so I need to do string explicit here, and then I can return items, right? So that's the third usage of a vec. The next one is gonna be some functional programming with vector. So I am creating a vec of strings, and I have A, E, and X, and I'm gonna do some functional programming and gonna print that result here. So if open functional prog, this is quite interesting what's going on here. So I have letters, which is a vec of string, and I'm gonna return a string. Then what we do is I'm gonna do a iter to iterate that vector, and then I want to apply some functional programming. I want to do a filter, and this filter I want to get each string. But as you can see here, we have two views of the string. We have two amp signs there, right? And I want to get the value of that string. So that's sort of other Rust thing. I need to dereference that twice because there's two amps. If there's just one amp, I could just do like that, right? So because there's two amps, I need to dereference twice, and then this I can get the value, and then I can compare this string with this other string. So basically what I'm doing here is asking, is this A, E, I, O, or U? If it's A, E, I, O, U, it's a vogel, all right? So I want it on, so I want a filter on. Otherwise, I don't care, drop it. So if it is a vogel, then we're gonna do a map operation, and we're gonna get this string as a V, and this string is gonna be turned into uppercase. That's what our map function is doing, and then we're gonna collect that in a vector, because otherwise it wouldn't be a collection, right? And once I have that, I have in result a vec of strings, and then I want to apply join, because I want what I want to do is between every single string I want to add a comma, and that's how we do that. So that's how we do some functional programming with vectors in Rust. That was this here. So here we're passing parameters and we're receiving vec as result as well. Now, let's do some contains. How can I check if a vector contains a string or not? So I created some vec of strings, Diego, Clara, Melina, and then I'm checking if Clara is there and if Dino is there. So I have this function called vec contains, where I receive the string that I'm searching for and the vector of string, and I return bool. And basically, I just do a for of the string in the vector, and then we do a pattern matcher here. And the pattern matcher is as the string, you're gonna be equals through the search, all right? If you know is not, meaning that's not the string I'm searching for, I'm just gonna ignore. That's the syntax in the pattern matcher to say I want to ignore that. Or otherwise, if it's true, I actually gonna return true because I found it, all right? And otherwise, I'm gonna continue the loop. And if this loop is done and I couldn't find it, I'm gonna return false. So that's how we can do searching for the exact match on a string in a vec. The next one I have it is how we can do some partition. So here I have a vec with numbers 1 to 9. And let's say I want to split this in two vectors. I want to have one vec of evens, another vec of odds. So, and here is the same reason like I did it before. I cannot borrow for a temporary, so I need to make everything like permanent on the lifespan. So here I'm getting that vec as mutable, right? Because I can't do it in one line. I can't copy it here and do as mut. It doesn't work. And then I have a mutable view of that vector, right? And then I'm gonna call vec partition, and then I'm gonna get a tuple of two vecs of I32, and the first one is gonna be the even ones, and the second one is gonna be the odd ones. So let's take a look on vec partition. So on vec partition, I receive A, which is a mutable vec of I32, and I return a tuple of two vecs of I32. And then what we do here is we do let even and odd. That's the name of the tuple we're gonna get. And the type of the tuple is a tuple of vec of I32s. So we're gonna get a view of the A, we're gonna dereference it to get the value, all right? And then we're gonna do into iter to create an iterator, and then we can call this partition method, and then we can send a filter closure where I'm saying that I'm calling this variable like view of n, and if n, in the case that's going to be I32, is divisible by 2, if the rest of that division by 2, it is 0, mean it's even. Otherwise, it's odd, and that's how we do this filtering. And then we just say like this, even and odd in one line, and that's going to be returned, right? So this is how we do partitioning. And finally, I want to show how we can concatenate vecs. So here I want to do something expensive. Very often you want to do the opposite, right? Because I'm using more memory. So I have 2 vectors and I want to allocate a third one. So I create the first vec, the second vec. So the first one has 1, 2, 3. The second has 4, 5, 6. And I'm doing vec concat new, passing these 2 arguments. And I have here a third vector with the merge result. So I have this vec concat new, where what I'm doing here on vec concat new is like A is a mut vec of I32, B is a mutable vec of I32, and return a vector of I32. Then I create this third vector, which is mutable, and it's called result, is a vec of I32, and I do that by doing vec new. Then I just do append, and then I do append of mut A and append of mut B, and then return result. In that way, I can concatenate 2 vecs, right? So we can run this code here, and we can see that the code works, right? And that's what I have for today on this video. I hope you guys like it. See you next time. Take care. Cheers.